Welcome to Books and Beyond. Today, I want to talk about a fascinating topic, the Mobius strip. What do you think will happen if I attach the two ends of this paper and cut it along the middle? So let me go ahead and demonstrate. And I'm going to go ahead and cut it in the middle. How many loops will I get if I cut this along the middle? Well, it's not a surprise that we get two loops. What do you think will happen if I do the same thing again, but this time I will attach it with a slight twist? Let me go ahead and demonstrate. I will attach this and make a slight twist, and I will glue it together and then cut it in the middle. But before I cut it in the middle, I want to demonstrate what happens when I take a pen and I do not lift the pen and I go ahead and I mark it starting from anywhere. I will not lift my pen and I will mark it along the edge. Surprisingly, if you could take a look at this, I have marked it on both sides. Now, what do you think will happen if I cut this along the middle? Hopefully I don't cut my fingers. Now, do you think we're going to get one or two loops? Surprisingly, we get only one loop. And what do you think this symbol looks like? If you said infinity, you are right. In mathematics, a Mobius strip is a surface that can be formed by attaching the ends of a strip of paper together with half a twist, which I just demonstrated. A Mobius strip is a mathematical oddity that anyone can make. The result is a one-sided surface. It was discovered by Johann Listing and August Mobius in 1858, but it already had appeared in Roman mosaics from the 3rd century CE. Mobius strips have inspired not only mathematicians, but also artists. Here's a mosaic showing Ion and the zodiac around 200 to 250 CE. Ion, god of eternal time, stands in the celestial belt of the ecliptic decorated with zodiacal signs between a green and bare tree, summer and winter. Before him is the Mother Earth, Tellus, the Roman Gaia, with 4 children and 4 seasons personified. The original is displayed at the Glyptotic Museum in Munich. Here is another example of a Roman mosaic representation of a Mobius band with 5 half twists. And of course, the famous MC Escher in 1963 created this woodcut print of the artwork showcases red ants crawling over a Mobius strip, which is a one-sided object that has fascinated mathematicians and artists since 1858. Escher was known for his brilliantly mathematically inspired artwork that played with geometry, symmetry, perspective, and tessellation. Most prominently, the Mobius band is often associated with the concept of infinity, and also with unity and non-duality. 2 sides and 2 edges are joined and become one side and one edge. To wrap it up, the Mobius strip, a fascinating mathematical concept, challenges our perceptions of geometry and inspires creative expression. As we navigate its single continuous surface, we find not only mathematical intrigue, but also a symbol of infinite possibilities in both art and thought.